Hello and welcome. Today we're going to be talking about complex numbers. Our main goals today are performing operations with pure imaginary numbers as well as what are called complex numbers. And then I can use complex conjugates to write quotients of complex numbers in something called standard form. So let's talk about something called imaginary numbers, something you could have or should have learned in Algebra 2. Imaginary numbers are numbers that can be written in the form b times I, where b is some real number and I is the imaginary unit. This imaginary unit is defined by the property that I squared is equal to -1, which in the real number system, anything squared is always positive, hence why this is what we call imaginary. One thing to note from this essentially means that if we think about I, it's the principal square root of -1. So I is the square root of -1 here. So a quick example just to show you this b times I, like that b could be any real number like 3i. That's just like an example of what a pure imaginary number looks like. So we're going to be using this imaginary unit I, which is what we have here. It's defined as the square root of -1. The fundamental imaginary unit I satisfies this equation that I showed you, basically square rooting both sides here. This property is what distinguishes imaginary numbers from the real numbers. And again, just to remember, any real number squared is always positive. That is one thing to know for real numbers. But imaginary numbers, when you square it, it will be negative always. So let's talk about a pure imaginary number. That just means the real part is actually 0, and there is just the imaginary part. So we know that I is the square root of -1. Well, what is I squared? This one right here is probably the most important, but this one is also fairly important. So I squared is essentially taking the square root of -1 but squaring it, which we already learned which was -1 on the other side. That's kind of how what defines it. Now, if I think about the next one, I to the third, we can think about properties of exponents. This is I squared times I to the first power, because we add 2 plus 1, which is third, which if you think about it is -1 times I, or in fact -I. That would be what that is. So I to the third is equal to -I. I to the second is -1. And I is just I. And then I to the fourth is probably the nicest of all of them because it's I squared times I squared, which is in fact -1 times -1, or we get this +1 here for that answer. So the nice thing about imaginary numbers, or pure imaginary numbers, they go on a cycle. So it will follow this and it'll loop back around, and those will always be the answers. Because every time we do I to the fourth, it will be 1. And then we can always take out I to the fourth or multiple I to the fourths. For instance, if I go I to the fifth, this is equal to I to the fourth times I, which that's just 1 times I, or I. Again, I to the 6 is I to the fourth times I squared, which we know what I squared is, which is just -1. And we can keep going down this list. It's I to the fourth times I to the third, which we know what I to the third is, it's -I, and then I to the eighth is equal to I to the fourth times I to the fourth, which is 1 times 1, or 1. And it will keep going down. These will repeat I, -1, -I, 1. It'll keep repeating all over and over and over again. So we're going to simplify a power of I. So we're going to look at just I to the 28th. And what we can do is we could split this apart in I to the fourth a bunch of times. This gets a little bit tedious, but there are in fact 7 of them. That's 5, 6, and then 7, because 7 times 4 is equal to 28, which we know that that's a 1 times 1 times 1 times 1 times 1, and that all is just equal to 1. So I to the 28th, because it's actually a multiple of 4, you divide this by 4, we'll always get to 1. Now, the easiest way to do this, to me, is just saying, well, what's 28 divided by 4? Well, this ends up being 7 with a remainder of 0. Now, this remainder is what we want. That's basically saying it's I to the remainder power. So I to the 0th power. Because all the other ones are going to equal 1. So I to the 0 power ends up being just 1. Now, I'm going to use that for this next one. So if it's I to the 63rd, I could write it out as I to the 4th all the way down, and then you have I to something left over. But the idea is just taking 63 divided by 4 and figuring what that is. Well, that is 15 with a remainder of 3. It's because 15 times 4 is 60. 60 plus 3 is 63. So the idea is there's 3 left. So this is essentially equal to I to the 3rd, which we know is negative I. So whatever that remainder is what's important, because this part will be turning into 1. That is kind of a quick way of doing all of this. So now that we talked through some pure imaginary numbers, now let's make them complex, meaning we're going to have both a real part and an imaginary part. So we're going to put in that real part as well. So complex numbers can be written in the form of a plus bi. That's called standard form. So this is the form I will want you to write every complex number. We should always have it in this standard form of a complex number. Now again, a happens to be real, and then bi, because it has an I, will be that imaginary part. So just a quick example, if I have 7 plus 3i, we know that a is 7 here. That's my real part. And my imaginary part, the b here, is equal to 3. So let's do a couple examples with adding or subtracting. So the first one is subtraction. And just remember, when you're subtracting a whole set or a group of numbers, the quantity of, if you want to call it that. So we're taking negative 2i minus the quantity of 6 minus 4i, meaning we're going to subtract the 6 and subtract the negative 4i. So just remember, this will have to distribute the negative. So this distributes. And what I would like you to do is write it as negative 2i and then minus 6, but then turn it into plus 4i. Because once you do that, it's an addition problem most likely. Or the fact is we can just combine like terms. So then we just combine like terms. Which, if we think about it, the negative 2i, negative 4i, or sorry, positive 4i turns into positive 2i, and then the minus 6. But that's not in the form what I want. Remember, I wanted an a plus b times I. So we just have to flip it around so that it's at negative 6 plus 2 times I. This is the form that you should have it in. I know your homework will probably be okay to write it this way, but I want it in that standard form. So now in this problem we are adding. So this is just drop the parentheses and combine. So combine like terms. That's the only thing we're doing here. So we put negative 1 and negative 6 together, which is negative 7. And then we put negative 6i, and then we put 2i, which is negative 4i. That is in that standard form, so that would be my answer there.